A lot of Power Query users know how to group their data, but not a lot of you know that the Table.Group function actually has a fifth parameter with a comparer function. And with that comparer function, you can define how you want to form groups when creating groups. And in this video, I'm going to show you how to build such a custom comparer. So let's say we have data with different capitalizations. If you would normally group your data, this is how it would go. You would right-click, Group By. There's a selection here. And what I want to group is the name column as shown over here. I want to show how many rows are grouped. And at the same time, I want to show which rows are grouped. So I'm going to select all rows. After pressing OK, this is what it looks like. So what we can see is we have groups of only a single row, which means that there were no similar groups that we could form. The reason is capitalization is different in this data set. Okay, let's have a look at Table.Group. So the Table.Group function actually has a set of arguments. And the argument that is not very explicit is, first of all, the group kind. So by default, this function uses GroupKind.Local. So if I enter this, nothing will change. What this means is that the logic will take the entire data set into account and will ignore the sorting order. Now, if we continue and we press a comma, we also can fill in a comparer function. And by default, Power Query uses comparer ordinal. So what this means is they use ordinal rules for comparison. So as you can see, nothing changes. However, it's important that you know this is in here. Let's say that we want to still group our data here, but ignore the capitalizations. So what we can do is we change the comparer ordinal to the other ordinal version, to comparer ordinal ignore case. This is a comparer function that looks if values are similar. And in this case, they will find it similar as long as the characters are the same, but the capitalization can be different. If we now click OK, we find that we get only 3 groups. So inspecting this shows that the 3 different versions of my name are considered the same group. Brilliant. Now, let's say that we want to build such a function like this ourselves. Let's see how we can do that. So instead of taking a standard library function, a comparer that we build always has 2 arguments. So I'm going to open a bracket and I'm just going to say X and Y. But in fact, it doesn't really matter what we do here. We simply define the parameters of our function, but we could have put different values here. And the start of a function is with the parameters followed by the goes to sign. And this is where we're going to define what we want to do. So if we would have been using our comparer function that we had before, we could simply take this and say X and Y. And if we close this down, I still need to define the name column here and the name column there. So let's stand still here for a moment. So X and Y in a comparer function, what are those? Basically, what a comparer function wants is they want to see if they're going to compare values, in this case, the values within the groups of our, within the rows that we're grouping. They want to be able to say like, I'm going to grab a row and I'm going to compare it to the next row. And then I want to see if they're equal, yes or no. So X and Y represent this. I see X as the current row and Y as the next value. Now, since we're grouping on, well, we only group on name in this case, but we might as well have grouped on multiple columns. So what I do here is instead of referring to X as the entire record, the row, I've specified a name here. So it's very particular about the name that we're specifying. So this is the name of the current row, and it will be compared with the name of the next row. And by doing that, it iterates over the entire table until it finds all of the groups that we have. Okay, so this still isn't very exciting, but we can make our own logic here. So if we want to replicate this, we could also do something like this. So there is the value compare function. Very similar to the other comparer, but this time we're not very explicit yet on that we want to make sure that texts are tested without respecting the capitals. So what we can do is over here I could say X name and Y name once again. And if I'm going to press OK here, we're going to have a different grouping, because right now it's going to compare all of these values as if they are to be grouped in this way. Now, if we want to do this case insensitively, we could write text lower for the first one here. And let me put this to a new line. And I would also put text lower over here. And we press enter. Now, what I'm doing is, for the custom comparer, I'm basically saying, first, make sure the name of the current row is in lower text, and then make sure the name of the next row we compare it with is also in a lower text. And based on this, make your groups. Okay, so here you got an idea of the first custom comparer. Let's see in what different ways we could use this. So here's the quarter. If, let's say we want to group all of these dates here, but there is actually not a quarter column and not a year column either. But our goal is to create groups of each quarter in a year. So let's see. We could again say we're going to group by. And again, I'm going to go for all rows. We call this details. And now we press OK. All right. Now, instead of making groups and capitalizations, we're still going to do GroupKind.Local. Very well. And for our custom comparer function, we're going to open a function, define them with X and Y, write the goes to operator. And now we're going to have to compare in some way so we can make sure that the grouping respects the quarter of the year. Now again, what we just saw, we can use value compare for this so that they will compare each of the values. And as values to compare, we could then say X date needs to be equal to Y date. Now, if we do this, we're just going to have the same table as we had, because nothing will be grouped. Let me see, there must be a mistake here still. I must be closing this one. That is the mistake. So nothing happened yet. Now the thing is, we want to instruct Power Query how to create their groups. So instead of saying just grab the date as is, we want to make sure we transform it to the groups we like. And there's a function for this. It's called date start of date start of quarter. And we do the same for the comparison value as well. Date start of quarter. There we press OK. Now let's see what happened here. So for the grouping, we transformed the date column to the start of the quarter. Now what that means is that the 1st of January, February, and March of the year 2000, those are grouped together within the same group. And the same goes for other periods here. Now what's so powerful here is that we can do that without adding a year column or a quarter column. It's all within the same Table.Group function. Okay, now let's say that we want to have a more specific comparer that will compare multiple columns for us with custom conditions. We can do that with a separate approach. Let's see how that works. So in this data set, we have two different columns. We have a column called period, and we have a column called product. Now, for this exercise, I want to make sure that we respect the cases of the period column, but we ignore the case of the product column here. How can we build that into our custom comparer? Now, first of all, we always need to group these two columns that are involved in the grouping. So you select them and you press group by. Now, it's just very convenient to see what we're grouping. So I'm going to add in all rows and call this column details. Okay. Now here's where things get interesting. So if we're going to be grouping things, for now, I don't really care about the data type. So I'm just going to remove this for the sake of simplicity. There we go. But nothing has been grouped so far. Each of the groups here has a single row. Now let's say what we can do. So we can first define our group kind global. This is the default. If you put null here, that's fine as well. Now up next is the custom comparer function that we're going to work with. Now in this case, we're going to need multiple conditions here. So on the next line, we're going to define the custom function with x and y. And I want to be able to make the product comparison ignore case and make sure the period is case sensitive. So let's start by ignoring case in the product. We're going to define a variable here, let, and I'm going to call it ignore case. Ignore case is compare ordinal ignore case, and we're going to compare the main product. So x is the current row and y is the next row. And then I'm going to just show you what the result is. Here we go. Just as a test to see if things work. Now, if I click here, we basically made a we made a comparison where we ignore the case of only the product column. That's it. That's all that we did. So if I inspect this, pens and pens are considered similar, so they fall into the same group. And shirt and shirt and shirt with different capitalizations, they are also considered the same group. Now here's something interesting. Now we still need to apply this to the period column. Now to do that, we can simply define another variable. So I'm going to add a comma here. We go to the next line. And I'm going to say like a respect case for comparer ordinal. There we go. And we have, we're going to apply that to the period column. So for the current row, we're going to have X, which refers to the current row. And we want to have that period. And then for the comparison value, we're going to need Y period. And if I only returned the respect case, then this is what the groups would be like. So I would have all of the day columns here. This day has a different capitalization, so they belong in a different group. And we have 2 of the years. Now, we need to be able to combine these together. So how does that work? Well, to understand that, you need to know a little bit more about custom comparer functions. So what does a comparer function require? So basically what the comparer function does is for the grouping operations, it compares each of the rows that are being grouped. And in that row, it will compare the current row to the next one. And depending on if they're equal or if they're different, you're going to get a different result. Now, in case the compared values are equal, the comparer function will return a null value. So 0 is that they're equal. Now, in case the first row comes before the second row in the grouping logic, for example, we might be grouping based on the alphabet, and the first one is the letter A, and the second value compared is the letter B. Then the A comes before the B, and the answer is -1 for the comparer. And last of all, you might have that the B comes as the current row, and that the A is the next one. And then we say that the B comes after. Now, how can we show this? If I, for example, just would write comparer ordinal, I could say I have an A here and a B. And if we look at the answer, it says -1. So the A comes before the B. But if we would switch this around, we would see that the B comes after the A, and that's why it gets a 1 value. Last of all, if the values are equal, we're going to see a 0. So in this grouping behavior, it will fall within the same group. That's what you should remember. If the comparison returns 0, they fall in the same group. Okay, so knowing this, how can we make sure our answer gives us a comparison that respects the case for the period and ignores the case for the product? We can do that as follows. In our result, we can say if ignore case, that this is our first comparer function up here. If this value equals 0, then I want you to return respect case. So what that means is it will then test the next condition. However, if the first comparer function is not 0, then it means it's either -1 or +1. And in that case, the values will never fall into the same group and are split up. So what I could return here is say else, simply return me the ignore case value, because the comparer function needs to have a symmetric result. What that means is it has to have a -1, 0, or 1, so that it has the right values to order each of these in the table. Therefore, I cannot just say that the result is a fixed 1 or a -1, because depending on the order of the values it receives, it will need a -1 or a +1. Okay, so we could say ignore case, and if it's 0, then we're going to have the respect case and press OK. Now check this out. If we're gonna look here, we have table 1, pants. That's fine. The second line also has pants here in the product. Now these are grouped together here. It ignores the product here, the product capitalization, but it respects the period. That's what we needed. That's what we were working for. No, I'm pretty excited about this. And I think it should make sense because it helps you make such custom forms here. And we finally get to number 2 here, where the shirts are different and the year is identical with the casing. That's what you can do. Now, there's some important stuff that we haven't talked about yet, which we will do now. So far, we have looked at GroupKind.Global. And in GroupKind.Global, it's very important that we have symmetric comparison functions. However, sometimes you might be using GroupKind.Local. GroupKind.Local can respect the order of your values. Let's see how that could work. Because in those cases, we can resort to a shortcut with a simplified custom comparer. Now, here I have a data set which is derived from a pivot table. So the pivot table had a value here. Then it had 2 null values below, because in Excel, you could also say that the values don't repeat. But when we get it in here, you might actually want to group these values so that 2001, actually all of these here belong to that location ID. And these belong to 2002, and these belong to 2003. Now in this case, the order of our values is super important. Let's see how we can use that with Table.Group as well. So I want to group my data by location ID. So I could go and I say right click, group by, and I'm going to have an all rows. Oh, this is going to stay count rows. And we're going to have another one which has all rows, details. There we go. Now here's the thing. I now have a single row here. The null values are grouped together and we have a table. So that's not what we're looking for. So first of all, we're going to specify a group kind, and the group kind will be GroupKind.Local. There we go. So now instead, we have the 2001. Then we have the 2 null values that follow, Bob Smith and Carol White. That is exactly in the order that's here. And that already shows that the order is respected by using GroupKind.Local. Now here's the thing. We actually want to group them differently. So every time that we find a number value, we want a new group to start. And we can specify that with a custom comparer. So let's say we're here. I could define a new custom comparer. So we're going to be X and Y, the goes to sign. And what we can then do is say, okay, I want the location ID to be a number. Now here's the thing. You might remember that the comparer function expects a 1, a 0, or a -1. But since we are doing a local grouping here, GroupKind.Local, we're going to respect the order, so we only need to look at the next value. So the next value is the y over here, and that's why we only specify the y. But we need this y to be a number. So this part will return true or false, but we need a comparer function to show a 0 or a 1. So we could add number from, close our brackets, and then check out what happens. So each time that the custom comparer function finds a value that matches here, it forms a new group. So if you're going to check if the thing is a number, then it's going to find this. Is this a number? Yes. Is this a number? No. This is a number? No. But this is a number. And then it's twice no. And then it's a yes. And it's twice no. So every time it finds a match, a new group is formed. What does that mean? That means that right now we have a group for the first values, we have a group for the second values, and we have a group for the third values. Now what's awesome is, with this type of grouping, I could just add my own custom logic to combine the names together. For instance, if I want to show the names together, I could write a new part, and I say it's called names. And then I just write each text combine. A text combine works with the list. So if we're referring to the names column, I could then have a separator of a comma and a space. Close the brackets, press OK. Now look at this. If I zoom out a bit, you actually find that we have the grouping of all the names in a really awesome and short way using just the comparer function. Now that's pretty awesome, right? So this step turns into this one, just like that. Now, actually, there's a lot of ways we could have done this, because right now we checked if this one was a number, but we could also have checked whenever something was not equal to null. So instead of looking at a data type, we could have written that this column is unequal to null and everything will stay the same. Now, the benefit of the simplified approach here is that it's a little bit easier to write. So GroupKind.Local does not require both the current row's value and the next row's value specified. Now, I imagine that was a lot to take in. It's a complex topic, and I know a lot of you are not on this level yet. That's okay. I hope you were able to follow along though. I got a few of these examples on my blog. So if you want to, find the article in the description below, and you can simply download the file and copy paste the code with it. Now, if this is something that you like, we also have a book release called The Definitive Guide to Power Query M. So if you want to get into the really nitty gritty and know how to work with this, I recommend checking that out because I think it will really help you. Now, this is complex stuff. This is hard. But if you need any help with this and you feel like it's worthwhile to explore this, just drop a note in the comments and I might write an additional blog post about this. Now, I want to thank you for watching and I'll see you in the next video.